Yes, sir.
Algorithms, containers, iterative. Communication will be like this. No direct communication. This is entire thing is nothing but it is STL. So before going to discuss about this, I will explain you this concept with one real-time example. So we people are playing games, different genres. See, I'm taking one character. I'm taking one character. With the help of this, you come to know what is this exactly. I'm taking one character. I'm taking one character. This is the character. So now you take any genre. I'm taking like some uh, yes, this character is. See, you please tell me how many genres are there? Hello? Genres. Hello, students? Students, are you
Yes,
there?
Yes,
Yes.
sir.
Give me a list of genres. Games.
There's
Hello.
action, sir.
Ah.
RPG is there. MMO
Hmm.
is there. Battle Royale is there. Hyper
Okay,
casual
no.
is there.
Yes, action means
Mostly there is a lot of action in there, sir. As in
action
a
means
lot of physical activity, some fighting is there, shooting
yes,
is
yes.
there.
That means hero, enemies, correct?
Yes.
Yes. I will take that genre that is action. I will take that genre that is action. Just imagine this person is a hero. Okay, he will fight with enemies. Normally, just imagine he knows he knows how to fight with enemies using karate. He knows karate. Just he knows karate without using any weapons. So he knows he learned karate, taekwondo, kung fu art, whatever it is. He knows one martial art that is karate. With karate, now at present, just assume that with the help of this karate, he is fighting with enemies. He is fighting with enemies. Okay? You people are playing games, especially in action genre. Most of the students, most of the people, they will like action genre games because fighting is there. See, now he is fighting with enemies with karate. Now, see, hero is having some powers, enemies also are having some powers. With karate only, he cannot fight with enemies. Am I correct or not? Sometimes it will work. Sometimes it doesn't give that much energy to fight with enemies. Am I correct? Just
Yes, sir.
correct or not?
Yes, sir.
Yes. Yes, yes. We need we need some extra weapons. We need some extra weapons. So, what are those weapons? Just I'm writing here. Weapons are uh, just I'm taking a gun, okay, and just I'm taking few sword, gun and sword. So just imagine here he is having some gun. Different types of guns are there. Just forget about that. Other than this, his own art, that is a karate, he is having some extra two weapons. They are nothing but it is gun or sword. Now, see, he's having gun, he's having sword means you have seen this in action genre games. To place gun, to place sword, that hero will be having some placeholders. Am I correct? Like bag. Am I correct or no?
Yes, sir.
Correct? Yes.
Yes, sir.
Yes. So I cannot draw all those things exactly. Just I'm drawing here. Just imagine this is like a pocket. It's like a bag. It's like a placeholder. Just imagine for gun there is a some separate placeholder. For sword there is a some separate placeholder. But here I cannot draw both separately. Just I have drawn one bag. So which contains gun and sword, extra weapons, extra weapons. So now, because this is very very important, we should be differentiate what is algorithm, what is iterator, and what is a container. That is very very important. So now he is having already his own one martial art, that is karate. Extra he is using gun and sword. See, just tell me, he is using gun, sword, or some other weapons. He must know how to use gun, how to shoot gun, how to place bullets inside the gun. Am I correct? I'm asking
Yes,
you
sir.
few questions. They are very, very important. How to use, how to use, next, uh, how to shoot, how to use means that is how to shoot, sorry. Next, how to fight with sword. See how to shooting, how to shoot or how to shooting, and how to fight with sword. We can call it as like sword fighting is also there. You know that?
Yes, sir.
Yes, sir.
Yes, sword. How to see? This is the procedure actually. Correct. How to use gun, how to use sword, whatever it is, how to shoot and how to sword. He must know that. What is this? This is called. We can call it as. It is a procedure. Am I correct?
Yes, sir.
See, without knowing how to shoot, how to sword, how to use gun or sword, even if you have weapons, it's meaningless. Correct?
Yes, sir.
Yes. Now, these are the weapons, gun, sword, and everything. Now, he know how to use, he know how to shoot and how to sword, but these weapons are available within his placeholders, gun and sword. Whenever there is a necessity to use gun or sword, what he will do? What he will do? See, gun is in one placeholder, sword is in placeholder. He know how to use it. He gets some situation to use gun or sword. What he will do? Tell me.
Sir, you use either one of them.
One of them. Use means how he will use it. First of all, see, these
Step
weapons
by
are in
step.
placeholders.
He'll remove it from
First
the
step.
inventories.
What? What?
He'll take it from the placeholder.
He will take it. He will take it. Correct. He will take any gun or sword from placeholders. How he will take it? How he will take it? Just generic only. Don't think like more logical. How he will take it? See, there is a mobile in your pocket. How he will take your packet? How he will take your mobile phone from your packet?
Sir, we'll put our hand inside our pocket and remove it,
Correct,
sir.
correct, correct, correct. Yes, generic. Yes.
Similarly, we'll
How?
take the gun out of the holster.
Yes, that means see. That's what. That is very, very important point. I'm taking that is hand. Correct. Correct. Hand. See, with hand, whenever there is a necessity to use gun or sword, with the help of hand only he will take it. Correct? Correct or not?
Yes, sir.
Yes,
Yes,
yes.
sir.
Now you see this. Again, I am telling you the story. There is a hero. He knows. He knows karate very well. Next, he is fighting with enemies. But karate, sometimes karate is not, it will not work out with to fight with enemies. He needs some extra energy. That's why he used some extra weapons. They are gun or sword. He placed all those things within one bag, that is nothing but the placeholders. Even though after having all these things, he must know how to use it, how to shoot, and how to fight with sword and everything. Next, after knowing all these things, whenever necessity comes, he will take out gun. Already he knows how to shoot and how to sword. Then he will start fighting with enemies. Correct?
Yes, sir.
Yes. Now, you please see this. Now I am writing. You please compare. This karate, okay, this is already you know this basically, correct? Okay, students, karate is this martial art, you know very well about this. This is called C++. Okay, so whatever the character I have drawn here, just imagine that's you. You know C++. C++ means whatever we discussed till now. You learned about C++ previously in last semester. Now also you know about C++. Just imagine after knowing only C++, you can do few things with only C++. But few things, that means for few requirements, it is not possible to work on C++. Okay, it is not possible to work on C++. Same thing. How he thinks that with karate only I cannot fight with all enemies. Same thing with only C++, we cannot implement applications for all requirements. Understanding?
Yes, sir.
Understand? Yes, yes. So, how he is using extra weapons? How he is using extra weapons and all? So that's why here to face to face or to implement all difficult, different applications which are not done by using C++. Here also we are going with new concept that is nothing but that is nothing but see, I'm combining all these things. This is called, what is this, students? What is this,
STL,
student?
sir.
STL. Understood?
Yes,
Having
sir.
we come to know that with karate only he cannot fight with all enemies. Same thing with only C++, we cannot satisfy all different applications. See how he went with extra weapons. Same thing here. We need to learn STL, Standard Template Library. Okay. In yesterday's class, I told you standard template library, it's having three major components. What are those? What are those? Algorithms, containers,
And iterator, sir.
iterators. Okay, algorithms, containers, iterators. Now, whatever you use procedure, this is called algorithms. Understood? Understood, students?
Yes, sir.
Algorithms are nothing but it is a procedures.
Yes, sir.
Next, there is a placeholder observed. Bag.
Yes, sir.
Bag. This is called container. Observed. Okay,
Yes, sir.
called container. See, he know how to use it. He know how to shoot, how to fight with gun. You know how to use sword. That is for sword fighting. He's having all weapons. Just now, you people said that whenever there is a necessity comes, he has to take out. Correct. Suppose, just imagine, if you don't have hands, if you don't have hands, you know how to use it. You have a weapons. How we will use it? How we will take out? Tell me. Tell me.
We're using hand.
Without hands, just imagine if you don't have hands,
We can't, sir.
we cannot. Correct.
Yes, sir.
That's why here, even though it knows algorithms, even though he is having a container with different weapons, without hand it is not possible. See how algorithms are communicating with container. Tell me. How algorithms, you know how to use. You have weapons. Can you use those weapons after knowing algorithms without hand? Without hand? No, no,
No,
correct?
sir.
Yes. That is called iterator. That is called iterator. Now understood? In last class, remember I told you one important point about iterator. I will show you this. You read this iterator. What is this iterator? Students, please. What is iterator?
Mediator between algorithm and content.
You see this? Is this correct or not?
Yes, sir.
Will you accept this? Will you
Yes,
Yes,
sir.
accept
sir.
this point? Yeah, yes. That means without iterator, here iterator is hand only. Just imagine if If you don't have hand, if you have algorithms, if you have weapons, how we will take out? Same thing here. Iterator is nothing but it is a bridge between, mediator between algorithms and container. I'm telling you the concept in high level. Okay. Now go to the algorithm. Just you see this diagram. What is an algorithm? It is like a procedure, correct? It is like a procedure. It is like a
Yes, sir.
procedure. That means how to use, how to shoot, and how to fight with sword.
Methods. Yeah.
Ah, yes. If you see here, algorithms are nothing but it is methods are built-in functions. We have a different types of algorithms, students. I'm telling you, under this STL, it is providing, under this STL, it is providing almost all 50 plus algorithms. 50 plus algorithms. Sir, what are those algorithms means? Just for example, here I have given sorting and searching. Other than this, it is having a different classifications. Once we start algorithm, then you come to not present, no need. Almost all it is giving 50 plus algorithms, built-in methods. That means algorithms are nothing but the procedures. 50 plus. Very good. Built-in methods. Algorithms are nothing but it is a built-in methods. Now, you please see this. What is container? What is container? It is built-in classes used to maintain the data or contains the data. How many containers are there here? You please see, I have given few containers. Vector, list, DQ, stack, queue, set, multiset, map, multimap. See, each and every container is having its own functionality. But here, what are the, see, container, that is a container. Inside that container, many different types of containers are there. What are those? Here, it is a container, it is a placeholder. Gun is a one container. Sword is a one container. How we have here vector, list, DQ, stack. Same thing here. We are having a gun, sword. You take some other weapon. Understood?
Yes, sir.
Did you get clear picture?
Yes, sir.
Okay. So here you have to remember that without iterator, without iterator, algorithms cannot communicate with container. That is very, very important. Here, you must know why, sir, why we must use iterator. Without iterator, can't you work with container directly? Yes, without iterator also, you can work. But here, don't take, sir, without hand, how can we do that? Means, just for this, just ignore that. Without iterator, how can we work with container? I will tell you. Algorithms inside this, and one more thing, students. If you want to, I told you how many algorithms are there, means 50 plus. How you will get this 50 plus algorithms means it is having one header file. It is having one header file. What is that? You must include this header file. HEADER. How we use IO stream, how we use type info, like that. You must use header file. What is that? Algorithm header file. You must include it. Algorithm. For example, algorithms are M algorithms. You have M algorithms. Just imagine. You have M algorithms. You have N weapons. You have N weapons. N weapons. See, if there is no iterator, for example, gun is there. Here, just I am taking, these are the algorithms. 1, 2, 3. These two are the weapons. 1 2. See how many steps are there, in how many algorithms are there in this case? Just tell me how many algorithms are there here. How to use, how to shoot, how to sword. Okay, how many weapons are there?
Oh,
Gun, sword. Okay, now
Yes,
you
sir.
see, if there is no iterator, what will happen? Just I am writing here how to use gun. I'm talking about gun. How to shoot gun, how to use gun, how to shoot gun, uh, how to how to use gun, how to shoot gun, and next how to fight. That is better. Okay, how to shoot gun. So instead of this, just I will take, just I'm modifying this algorithm. How to use, how to how to how to use, and then how to fight, and how to place. Just I'm writing how to place, how to fight. Now you see how to fight with gun, how to fight with gun, how to fight with gun. Next, how to place gun. This is for gun. See, i have applied I have applied all these algorithms, for all these weapons. See, next I'm applying three algorithms to second weapon. How to use sword, how to use, sorry, how to fight, with sword, how to place sword. uh, how many implementations did you get? How many implementations? See, students, I have applied these three algorithms to these two weapons. Observed?
yes, sir.
So that means same algorithm you applied for different weapons. Observed?
Yes,
Yes,
sir.
sir.
Same algorithm. How to use gun, how to use sword. How to fight with gun, how to fight with sword. How to place gun, how to place sword. Okay?
Yes,
Algorithm,
sir.
algorithm is common for different weapons. So one weapon is works for different algorithms. Now, how many implementations you got here? Tell me.
6.
6.
6 implementations. 6 implementations. This is very, very important. See, if there is no iterator, you will get 6 implementations. That means m into n. Here, what is m? The value of m is 3, value of n is 2. Value of m is 3, value of n is 2. You will get total 6 implementations. Just imagine if it is having 50 algorithms, 50 algorithms, here how many containers are there here? 9. If I take for this 9, how many implementations you will get?
450.
Huh? 4
450.
and 4 and how much?
So 450.
450 implementations, m into n. If you place iterator, what will happen? If you place iterator, no need of giving that many implementations. How many implementations it requires? Please see this. What it is?
M plus
M
N.
plus N.
M plus n. So in this case, instead of giving 450 implementations, it gives only 59 implementations. 59. Here, algorithm doesn't know it is working with which container. Container doesn't know it is using what algorithm. Getting my point?
Yes, sir.
Iterating is
Yes,
the
sir.
medium algorithm. It doesn't know on what container we are applying that algorithm. Same thing, container doesn't know by using what algorithm it is giving result. But who knows about all these things means iterator. Why, sir? Why we must use iterator means see how it is decreasing the number of implementations. You imagine 450 implementations and 59 implementations. Is it reducing? You see,
Yes,
where
sir.
is 450, where is 59? Almost all you are
Big
reducing
difference.
400 implementations. Understood? That's why, see, now I told you finally how STL will works. That's why STL is, it is the heart of the C++. It is heart of C++. It's a very optimized library which is available within C++. STL provides a perfect environment, good environment to write a program, to write a program more efficiently, more efficiently. Finally, I can call STL is more reusable. It's a robust, it is a robust, more reusable. It's having a more readability. Understood this? You see how you are reducing the code. Am I correct or not, students? Hello,
Yes,
will
sir.
you accept this
Yes, sir.
point?
Very much. Big
Yes,
difference.
yes,
Yes, sir.
yes, yes. That's why. And one more thing is, uh, shall I share this screenshot? If you want require this, I will share. Otherwise, no need.
Yes, sir. You can put it on the group, sir.
Yes, I will save this.
Sir, Prathamesh is waiting to join the
Oh,
class.
sorry, sorry, students. So I didn't get request. If I try. Yes. Now, yes. Now understood, students? Clear? Up for now, till present, anyone is having any doubt?
No, sir.
Yes, sir.
No, no. See, yes, I will tell you next. I will take a new one. Now this is very very important. You please tell me, will you accept this one? STL is, it is generic programming. Generic programming. Am I correct or not?
Yes, sir.
Yes, sir.
What is generic programming, students?
Can be used for all. It's common for all, sir.
Correct? Yes. Generic means it is common. Generic means it is common. Now, We discussed about this generic programming on behalf of templates. Remember? Templates. Templates are two types we discussed. One is on behalf of function template. We have seen, correct? On behalf of classes.
Yes, sir.
We discussed a lot about function templates and class templates. What is a function template? Just tell me in single word.
For a function that can be used for multiple different things,
If you write one function template, it works for
different data
all
types.
data types, correct?
Yes.
Yes, different data types. Different data types. Same thing, even though it is a class means it works for different data types only. Am I correct?
Yes, sir.
Yes, sir.
Yes. So that means you will write same function for different data types. You will write same class for different data types, correct?
Yes, sir.
Only one
Yes, sir.
function for different data types, one class for different data types. One function for different data types, one class for different data types. Now, you should tell this. Same thing, one algorithm for different containers. Getting my point? Hello?
Yes, sir.
Yes, sir.
How to use algorithm for different containers. One is for gun, another is for sword. How to fight algorithm for two different containers. One is for gun, another is for sword. How to place is algorithm for different containers. For gun, for sword. Getting my point?
Yes, sir.
Yes. That is here. What does it mean? So that's why template is STL is giving, it's a generic programming. STL is giving generic programming. STL is giving generic programming. So that's why we can call it as STL is a standard template library. You can call it as like template programming also. This is the concept we are using. Why, sir? Why STL is reducing the code? Why it is reducing? How can you say? Sir, it is a generic programming. See, one algorithm for 10 containers. That algorithm is generic for all these 10 containers. Am I correct or not?
Yes,
So
sir.
that is called, it is a generic programming. Definitely you can reduce the code. You can reuse the code. You are reusing the same algorithm for multiple containers. That's why STL is a reusable, reusable, reducible, reducible, and reducing the code. And next is robust. Robust means, see, it is working with the different types of containers, means definitely it is robust. Robust. Yes, till now we justified that statement. STL is the generic programming. Well and good. Now one more important is, I'm taking OOP concepts. OOP. What is the full form of OOP, students?
Object-oriented programming, sir.
Object oriented programming. Here, under this OOP, there is a one concept that is called encapsulation. Encapsulation. What is encapsulation? Tell me. What is encapsulation?
Sir, bundling together methods or functions.
Hello?
Sir, I said bundling together methods or functionalities
Functionalities?
is encapsulation, sir.
Yes, yes. Any other? Yes, whatever you said, that is correct. Any other?
Class.
Huh?
Class.
Ah, okay. Ajay, he said that one definition, and another one is they have given one example. What is that? Class.
Yes, sir.
See, we are keeping data plus functions, correct? Or methods within one capsule. That capsule is nothing but what is that?
Us.
Class. That is called encapsulation, correct?
Yes, sir.
We are keeping data and functions. See, just forget about STL now. Just whoops and generic C++ programming. You are writing one class. It is having some data and functions. You please tell me how you will store the data. Tell me how you will store the data. You are writing one. You are writing one
Objects.
program with the how you will store the data with the help of
Objects.
objects. That means object of class. Again, if you go in detail, how you will store
Variables.
the data? Yes, variables. At present, just variables. With the help of variables, you are storing the data. See, once you store the data with the help of variable, how you will do operations on the variables by using functions only, correct? Without functions, how we will use those variables? Am I correct or not?
Yes, sir.
Functions.
We need
Functions are
functions.
nothing but methods. With the help of this, what you will do? What you will do?
Operations.
Operations. Just imagine. See, we have a class. Class is having some variables. Variables are having some data. Variables are having some data. If you want to modify it, if you want to do something, if you want to manipulate that data, the data which is available within variables, how we will do that? By using functions. Functions are nothing but methods, correct?
Yes, sir.
In normal C++, in whoops, how you made both variables and functions?
Inside a
Variable
class.
inside a class. That means you both are combined into one unit that is called class.
Yes, sir.
What is the use of variable here?
To store
Use of
data.
to store data. That is very, very important. Variable is to store data. What is the use of these functions, methods?
Operations.
That is operate on data, correct? Operate on data. So finally, variables and methods both are combined into a single unit that is called class. This is nothing but it is OOP, correct? Whereas STL is opposite to OOP. STL is opposite to OOP. Sir, how it will opposite to OOP means on behalf of this concept. Here, what you did here, you placed data and functions within a single unit, within a single container, the single place that is called class. Whereas in STL, it is opposite to OOP means you are separating the variables and you are separating the variables and you are separating the methods. Both are separated, both are different students, both are different. Here this is called you will store the data. Here you will operate. That means it is having some methods. Sorry. So data and methods are separated. Data means here variables, correct? In STL, where you will store the data? Where you will store the data? In STL. Where you will store the data? Tell me, students.
Containers, sir.
Containers. Where you will store methods?
Algorithm. Uh,
Yes,
algorithm, sir.
algorithms. You please tell me container is different, algorithm is different, no, in STL.
Yes, sir.
Yes, that's why I'm justifying you this statement. STL is the opposite to.
Oops.
Oops. Here, how we will store the data means, in this case, yes, it is a variable, but in containers, it is having a different containers. They are called as classes, template classes. They are called as template classes. Here, algorithms are having a built-in methods or built-in functions. They are called as template
Functions.
functions. Getting my point? So containers are having a template classes. Algorithms are having
Template function,
template
sir.
functions. Both are separated. Will you accept this point or not?
Yes, sir.
Yes. See, in Whoop, both are combined. In STL, both are separated. So in Whoop, if you want to implement like this with the help of normal generic class programs, the code will be more. In STL, we are separating. Both are located at different places. That's why here there is more reduction of the code. There is more reduction of the code. Okay? Okay, students?
Yes, sir.
Yeah. Finally, container contains template classes. Algorithm contains template function templates. Function templates. Yes. I've stored this. I've stored this. So now, see, in our syllabus, uh, we need to discuss all algorithms, we need to discuss all iterators, we need to discuss about all containers. First, let me start with containers. In single line, I am telling you the definitions about all these things. Algorithm operates on data, which is held by containers. Container holds the data. Iterator, iterator, it acts as a bridge between,
Container and algorithm, sir.
yes, container and algorithms. Okay? Yes. So now, this is the last point. One more is algorithm. I'm writing you again. Algorithm operates on data. Container holds data. Iterator bridge between both. Correct?
Algorithm and containers.
Yes. That means that means it is pointing it is pointing data, it is pointing data on behalf of algorithm to container. In generic, you can compare, it is nothing but pointer, it is nothing but it is a pointer. Always iterator, it works with memory address. You remember this point, student, this is very important. Iterators are nothing but they used to consider memory address. What is the use of pointer? Tell me. What is the use of pointer? It holds the address of a variable, correct?
Yes, sir.
Yes, sir.
Same thing here, iterator is nothing but, yes, it is a bridge between algorithm and container. Sir, how iterator knows the data within a container means by using its
Memory address.
memory address. That is nothing but it is a location. By using nothing but it is a location. So now I will take you one example. Int a of 2, int a of 2, int int instead of a of 2, just I am taking a is equal to some 10 int star p, int star p, that is a pointer variable. P is equal to address of a, p is equal to address of a. Now C out star p endl. Okay, now here you please tell me, just analyze this small code, just analyze this small code, just analyze this small code. Here, what is the data?
A.
So data
What
is
is the data?
10.
10.
What is the data? 10.
10.
Yes, yes, yes. This is data. Where it is?
Stored inside of A.
Inside of
A.
A. What is this? Is variable, correct?
Yes, sir.
What is this P?
Pointer.
What it contains?
Address of A.
Address of A. Correct? Now I am telling you, 10 is the data. Variable is container. Variable is,
It's
it is a
container, sir.
container. Okay? And here you declared pointer. Iterator. Observe. Pointer is nothing but it is iterator. Now P can store the address of this A. Here what is A? A is a
Container.
A is a container. Now understood this? Now
Yes, sir.
understood this? See, we have a one container that is called vector is the one container. Vector is the container. So if there is an iterator, iterator can hold the address of a vector. Okay? If you take list, iterator can contain address of a list. Am I correct or not? If there is a container DQ, iterator can contain address of a DQ. Getting my point?
Yes, sir.
Yes, yes. See, this is one of the simple example. And iterator means it always pointing to the memory address. Based on this concept only, we can call it as it is works like a pointer. It works like a pointer. Pointer means it always refers address or location. So same thing, iterator also, it always works with locations or memory addresses. You remember this. Because of this only, it is going to interact with the container. It never and ever directly interacts with the data. It simply holds the address of the container. After knowing the address, then it will start playing with the data which is held by the container. Okay, students? Okay, students?
Yes,
Yes,
sir.
sir.
Yeah. Now wait. Yes. So now we are jumping into the programming side. This is like a basic information. Any doubt regarding this about algorithm, about iterator, about container in high level, you please ask me. Anyone is having doubt? Anyone is having doubt?
No, sir.
No, no? Yes. So now we start work with first container, students. What is the first container?
Vector.
Yeah.
Vector. We can call it as it is looks like an array. It is a sequential memory allocation. It works like an array, but we can call it as vector is a wait.
Dynamic array.
Yes, vector is a dynamic array, and it works like a smart array. It works like a smart array. Why it is smart, sir? Why are you calling vector is a smart array? Means in array it is having a one drawback. Yesterday's class we discussed. What is that? We cannot change this size. We cannot change the size. We cannot remove the size while inserting, while deleting. That is the problem with space. So that's why with the help of this vector, it added some cool, very good features. So that's why vector is a dynamic array. Vector is a dynamic array. How you perform insertions, inserting elements and deletion elements into an array. Same thing here we can do that. But here it is having some additional functionalities. We need to discuss about all those functionalities one by one. Now, you please tell me, vector, is it a container class or not? Vector,
Yes, sir.
is it a container class?
Yes, sir.
Yes, it is a container class, one of the container class. It is one of the container class. Very good. It's like gun sword. It's like a gun or sword. Now, is it that means vector is a container class, vector is a class. Is it template class or not?
Yes,
Is
sir.
it template class? Yes, it is a template. Template class means it can work with all algorithms, correct? It can work with all algorithms. This vector is a common for all algorithms. You can apply all algorithms for this vector. That's why it is a template class. So normally we have seen template class. Is it contains constructors? Template class.
Yes, sir.
Correct or not?
Yes.
Yes, template class is like a normal class. But it is a generic. It can contain constructors. No, correct.
Yes, sir.
Uh, it can contain destructors,
Yes, sir.
uh, template class. It can contain functions, member function.
Yes.
Correct. See, constructor is also one kind of function. So
Yes.
it contains constructors, destructors, and some functions. Will you accept this or not?
Yes, sir.
Yes, constructors, destructors, and functions. Now, you please see this. What are the member functions are there means, just now I told you, member functions, students.
Yes, sir.
Yes, member functions is, I'm taking this first function. Member functions, you please see this. Member functions, other than this constructors and destructors, it is having member functions. Member functions. What are those member functions? These are the member functions. No need to talk about constructors. With the help of class, name of the class only, you can create a constructor. But here, member functions are very, very important. The first member function is see this. What is the first member function? Tell me. First member functions on behalf of capacity. Based on the concept, you can classify all these member functions. On behalf of capacity, what is the first member function?
Size.
Size. For size, no need to use parameters, but what it returns, It returns the number of elements in a vector. It returns number of actual objects held in a vector, number of elements in the container. Here what we are discussing, are we discussing containers, iterators, or algorithms?
Algorithms.
Algorithms. Please see the students. Include, I will write IO stream hash include type info. What are right? What container class you are discussing now? What container class
Vector.
you are? Huh?
Vector.
Vector. Namespace std. So int main.
Sir, we'll have to include vector, na sir?
Ah yes. No. It first. I want to show you error. Then I want to include that.
Okay, sir.
Okay. No. Remember how did you create object for template class?
Class name,
Ah,
data type, and the
class name, angular
name of the
brackets,
object,
data type.
and then the name of the object.
Correct?
Yes, sir.
Correct? Yes, yes. Class name, just students before this, let me write down, just I'm writing template class T. Just I'm writing class T. This is a template. First I'm writing class A. You please see this carefully. See, it is having some data type and member functions. Okay. There is a constructor also inside this. A of, there is a constructor for this. T x comma t y. I am declaring some variables. Public int a, int b, these are the variables, and this is the member function. The member function means here we can call it as like constructor. What you will write here? A is equal to x comma, correct? B is equal to, sorry, B is equal to y. Here we are using templates, no? That's why here I can use capital T. Here I can use capital T. Okay, students.
Sir, we could use
Hello?
initializer list, na sir?
Huh?
Initializer list.
No, no, no. That is all our advanced. Just forget about now.
Okay, sir.
Now you see this. If we want to initialize these values, first we must create an object, correct? How we will invoke this?
A
Tell me, how do you create an object?
data
A,
type. I
data
mean,
type.
whatever data type you want, sir.
Yes, int. Then
Name of
name of
name of
object is
object.
small a. Then
Then insert parameters.
correct.
Yes, sir.
Now I will ask you few things. You please tell me, students. What are you doing here?
Initializing and declaring.
What is this?
Class name
What is the class name?
A, capital A.
Yeah.
Where is A?
So
Where
above
is A?
in the same program.
Here only, correct? Correct?
Yes, sir.
Where is A? Here. Who have written this class?
The programmer you.
Programmer. That is user defined, correct?
Yes, sir.
That is user defined. Please try to understand this. Again, I am asking you. We are discussing about this line only. What is A? A is a class. Where it is defined and declared? Here only. Who is the owner of this class? Programmer. Correct? Is it built-in class or user defined class?
User defined class.
The body and the declaration and definition is here only. Correct? Correct?
Yes, sir.
Now, please, students, if you catch this point, you can apply this concept for all algorithms, uh, containers, and all types of iterators. Now here into main. Oh, you please see this. Just I'm writing you. Just forget about this. Now, just now you have given explanation about this line, correct? What is A? Data type. You are passing these values. These values are stored inside this class. Now here, in this line, what is the class name?
Vector.
What is the class name? Vector, correct? Correct? Vector is a class name.
Yes, sir.
How A is the class name, vector is the class name. Here, where did you define this A? Here only. Who have defined user, programmer, user defined class. Now, what about vector? Where is the definition of vector?
It's not in this program.
Is it user defined class? Is it user defined class?
Sir, we don't know that yet.
No, vector. Is it user defined?
No,
Program
sir.
is writing about vector, implementation of vector.
No, sir.
No, no.
It's
Yes, sir.
already
Yes. Here, what is A? A is user defined
user
class.
defined.
What about vector? It is not
It is
user
built in.
defined. It is a built-in class.
Yes, sir.
Vector is a built-in class. If something is built-in, how you include that class to your program?
Header file. We have to include that header file.
Yes. Hash include vector. Now you understood? Here in this program, we don't have the body of the vector class. It's a big class. We don't have body. Hello? May I know
Yes,
who
sir.
is this? So body is not there, but we are creating object for that class. That is a template class. Those class definitions and everything are available within the one header file. You must include that header file. That is nothing but it's a vector header file. Understood now?
Yes,
If
sir.
you ask me, sir, where is the vector? Where is the class? Means it's already built in. That's why here, are you writing anything about vector code for vector class?
No.
No, just we are reusing. That is the concept of reducing the code. You are reusing that code. Correct. You are reusing the code.
Yes, sir.
Programmer is not writing the code for vector class. It's already built in. That's why reducing the code, reusability. See how much overburden is reduced on behalf of the programmer. Just you are using the concept of vector. That's it. What does it mean? Already body for the vector class is it's a written, just you are including, just you are reusing that. How you are using input output stream classes, how you are using type info header file classes, same thing here we are using the class about vector. Now understood? Anyone is having doubt regarding this? How we write an A? There is a vector. A is works for integer, float, any data type. Same thing, vector is works for any data type. That's why it is a generic class. It is a template class. Okay?
Okay, sir.
Yeah, good. Now, I'm not assigning you values directly. Just I'm declaring the variable. Now, yesterday only we did this. Type of V is, what is the type of V?
The vector.
Vector. Now, here, what is a vector? Vector is a array. Correct. Is vector is a, what is a vector? Vector is nothing but it is container class. It is nothing but it is
Array.
a smart array. Okay. Smart array means it's a dynamic. So what is the difference between array and smart array, dynamic array means? So in array we must give the bound of an array, but here no need. Here any element inside this array, v is also, it's like array variable. How array is having one variable, here v is also one variable. In array we must use the size of the array. Here no need of using size of the array. Now I will show you. Now, yes, type is over. Now you please see this. See here, one of the member function is size is the one of the member function. Now here I am using that. Any value inside this vector, is there any value? Any value?
No, sir.
No.
No data.
Yes, no data. First I am giving size. Size of V is V dot V dot
Size.
V dot included vector. Yes, included. V dot, you must get size. And then I'm running this program. Now size of V is
0.
0. Why it is 0?
Sir, we can't hear you.
Yes. Getting my voice, students?
Yes, sir.
Yeah. So now one more function is max size. One more function is max size. All these are the member functions, students. For max size also, there is no parameter. It returns maximum number of elements that vector can hold. How many elements can hold? Now, I'm using that function, same maximum size of this. Max underscore size of V is, function is V dot, V dot, max underscore size. See, that is the maximum. It's very bigger one. Size is more. Able to see this?
Yes, sir. Big number.
Yes, yes. Now, see, max size is over. What is the max size? Just now I have given this. What is the max size? Max size is nothing but, see, it returns the maximum number of elements that vector can hold. So now, capacity, one more function. It returns the size of the storage. It returns size of the storage. Third one, it returns size of the storage. You please see this. It returns size, no parameter, it returns size of the storage space currently allocated for the vector. Size of the storage space, size of the storage space currently allocated for the vector expressed in the form of elements. So here, this is very, very important. And one more thing is, it is automatically expanded by the container. Now I will justify you that statement, please. Now I am writing capacity. So capacity of V is V underscore capacity, V dot. Let me finish this, then I will stop class. Capacity of V is 0. That means here no size is 0. That's why capacity, storage is also 0. Now, now, if you see this, we have a one more member function on behalf of modifiers. You please see the students. Modifiers. We have a one more member functions on behalf of modifiers. What are the two different modifiers are? This is also one more type of member function. What is this first one, students? What is the
Pushback.
first one? Pushback. Pushback means it is pushing elements back end of the vector. Back end of the vector. Pushback. Yes. See, add new element at the end of the vector, last element. Here, is it having any elements in the current vector? Is it having any elements? No
No.
elements, correct. Now I'm adding the elements. You please see this. V dot pushback, push underscore back of 10. Pushback of 10. Now I'm displaying you After pushback, I am displaying you size and capacity. You please see this. This is very, very important. You please see this. Now, how many elements after pushback? You see this?
One.
1. Size of V is 1, capacity is 1. Now I'm adding one more. Just I'm copying in this. Pushback of 20. After this, I'm displaying size and capacity. Size is to capacity. Both are giving same result, correct? Capacity and size. We must differentiate it. That is very, very important. Setting 30. Now see this.
Capacity is 4.
Why?
Doubled.
Yes. Now, to get more clarity about this, I'm inserting 40. We'll take one more value. Now it becomes size is 4, capacity is also 4. Very good. Now we get clear picture. After inserting this 50, you come to know. With the help of this program, you come to know limitation of this vector.
Capacity is 8. Double.
Okay. Yes, I will tell you students how it is storing. How it is storing elements. Initially size is 0. Initially size is 0. That means no memory. When you start inserting one element, one block is allocated. Here you store 10, correct? So here size is 1, capacity is 1. Once you store another element, is there any space to store another element in this? Is there any space, students? While
Yes, sir.
inserting
No,
20,
sir.
is there any place? No.
No.
In that case, what it will do, it simply doubles the previous size. It doubles the previous size. Here the size is 1. Now it doubles the previous capacity. Now again, it is taking this, it is moving this 10 from this block to this block, and new one is inserted here. Observe? After inserting 10, after inserting 20. Now here size is 2, capacity is 2. Now, if you insert 30, is there any space for 30 here?
No.
No space. Again, it will create
Double
this
of
like
previous.
memory for this double of the previous capacity. Previous capacity is 2. Previous capacity is 2. Double of previous capacity is 4. Now it is moving all these elements 10 and 20 and then 30. See here, recreating the memory based on the size of the vector. If it is exceeding, it creates a new one, then it's simply starting copy, moving values from previous memory to this memory. This is the more headache from on behalf of vector. So vector, it is taking one of the major drawback of vector is it is time consuming, but we will ignore this. So why it will take more time means because of this reason only. When you insert 40, yes, there is a space. 10, 20, 30, 40. When you insert 50, when you insert 50,
No space.
size is 3, capacity is here 4. Here size is 4, capacity is also 4. No space. In that case, double of
Double.
the capacity. Correct. Double of the capacity means it will get total 8 blocks. Because you are storing integers, no? 1, 2, 3, 4, 5, 6, 7, 8. Now it copies all these elements. Then it will allow you 60, 70, 80. After 80, if you insert one more element, then it will start doubling. Am I correct?
Yes, sir.
Yes. This is the one of the drawback of vector, but we ignore it. Why it is drawback means this is the main reason behind the drawback. Okay, students?
Okay,
Anyone
sir.
is having doubt regarding this?
Sir, we
No,
can
sir.
reserve that memory space, right, sir?
Huh?
We can reserve memory space for vectors, right, sir?
Yes, yes, many functionalities are there. Basically, this is the concept. We will discuss many other functions. Anyone is having doubt regarding this till now? Clear? So we will
Clear, sir.
continue the concepts STL like this. Please don't miss classes. Okay?
Yes,
Thank
sir.
you. I will take your attendance. Please hold for some time.